Hello students, today we will solve for topic 10, that is fields, for MCQ paper 1. Okay, so before you start watching the solution, I will request you all to please go through the worksheet which I have uploaded in a PDF format. You can see the link in the description below. Please solve that worksheet and then watch this video for the solution. Okay, so as of now I am starting with the very first question. Which one of the following statement correctly, okay, it is asking correctly defines the gravitational potential at a point P in a given gravitational field. So we know that the gravitational potential at any point is defined by the amount of work done per unit mass in moving this test mass or a small mass from infinity to point P, because we know that the potential at infinity is 0. So from that point to point P, from infinity to point P, the amount of work done required is nothing but the gravitational potential. So the answer for this question will be nothing but your answer is B. So rest all are incorrect. For question number 2, an isolated point object of mass m. Okay, a mass m, capital M is the point object of mass m. A second small point object of mass small m is placed at x from the larger mass. So let us say this is my larger mass and this is my shorter mass. So this is capital M and this is small m, and these are at a distance of, let us say, at a distance of x. Which one of the following is a correct expression for gravitational potential energy of mass m? Now we know that what is the formula for gravitational potential energy. You can see the it is direct from your data booklet 10.2, the formula for like EP, that is the gravitational. In the subtopic 10.2 you can find out the formula. EP is equals to minus of G capital M small m upon R. So here the R is nothing but the x. So the answer for this is also B. It's very easy. Now question number 3, the center of two isolated spherical stars, so these are the of mass m and radius r, you can see, is separated by a distance x. The distance d, this d is very larger than the radius r. The point x is the midway between the stars. The gravitational potential at this point due to the two stars, so we know that it is a scalar quantity. So the gravitational potential at x, the formula is also given in your data booklet, that is minus of G m by r. R is the distance from this point. So from this to this is d by 2 if x is the midpoint. So I will write d by 2 plus of minus of G m upon d by 2. So this is 4 times of minus G m upon d. Okay, so this is your option A. Now question number 4 is a very direct question. Which of the following diagram best represent the gravitational equipotential surfaces due to two equal spherical masses? Now we know that when two equal masses are kept, okay, so these are the gravitational forces are of attractive nature. Okay, so we are supposed to choose the gravitational equipotential surfaces. Okay, so first and the foremost point is at the midpoint the potential will be 0. Okay, so this is, there will be no equipotential surface, or you can say the potential at that particular point is 0. So this is incorrect, this is also incorrect. Now remaining for B and D. Now if you see, the equipotential surfaces cannot be like this, because with respect to distance the potential decreases, and equipotential means the potential has to be the same at all the point. So this is also incorrect, this is incorrect, this is incorrect. So only option is B. So you can see here it is 0 and it is a concentric circles are forming. It means that at these all position the potential due to these two masses all are same. Okay. Now question number 5, the escape speed from a planet is defined as the speed at which an object must leave the planet's surface to. So it is direct question. We have discussed this, that the escape speed is the minimum amount of speed that is required for an object to move out of the gravitational field of that planet. So completely from the gravitational field of the planet, that is option A. Now escape speed formula, if you see, it is directly given as in the data booklet itself, under root of 2 times gm by r. Now you can see the escape speed is depending upon the gravitational constant, that is already given, and the rest two factors is the capital M. Now this capital M is the mass of planet, and small r is the distance from center of the planet to the center of the object. So the question is asking depends on which are the two factors. So capital M and small r, which is option A. It is very important to note here that it is independent of small m, that is the mass of the object. This is very important. Now question number 7. A planet is in a circular orbit of radius r about a star. The period of the planet in its orbit is t. A second planet orbits the same star in the circular orbit of radius rs. Okay, so let us say this is the time period t with respect to the radius r, and which of the following is the correct expression of the period of the second planet? So let us say ts, and this is having rs. Okay, now we have to find out the correct expression. I can do it directly, but you should know the relation is the time period square is directly proportional to the radius cube of the radius. Okay, radius of the orbit. So this is also the Kepler's third law, and how you derive this is in detail, it has not been asked, so you can use this relation, it is not given in your data booklet. So I just take the ratio, so ts upon t square is equals to rs upon r cube. So ts will be you can say rs upon r raised to power 3 by 2 times of t. That is option B. Okay, you can solve. This is a simple mathematics involved in it. If you didn't get it, just let me know in your comment box. Now question number 8 is a very good question. The two satellites X and Y move in a circular orbit about the Earth. The orbital period of X is 8 times. Now Tx, that is the orbital period, is 8 times of Ty. Okay, the ratio of the orbital radius. Now it is asking you the radius Rx upon Ry. So as of now we have already solved Tx upon Ty is nothing but Rx upon Ry. So this is the cube and this is the square. So Tx upon Ty is already 8 square. So Rx upon Ry ratio will be, here it is 3. So you can take 8 square is 64, and 64 power 1 by 3 is nothing but 4. So the ratio is 4:1, that is option B. Okay, so please make sure to avoid the mistake. I hope you get it. Also you can get the PDF of this whole solution. Again the link is given in the description. You can check. Question number 9. A powered spaceship is moving directly away from a planet as shown below. So this is the planet, this is the spaceship, it is moving away. This is point P. At point P, the motors of the spaceship are switched off, but the spaceship remains under the influence of the planet. It means it is still at this point, there is some gravitational field involved. Which one of the following graph best represent the variation with time t of the velocity v of the spaceship after it passes point P? So after it passes point P, as you see, as you are moving away, okay, the potential or you can say the gravitational force decreases because it is an inverse square law. So velocity will also decrease as it is moving away from the field. So among the given option, so here what is happening is it is moving, it is have certain, and then it is moving like this. This cannot happen because it cannot be in the positive always, it will be changing its direction. Here it is in the same direction, it is becoming 0, but again it is moving in the same. It means that it is traveling, velocity is decreasing, it becomes 0, and again it is traveling with an increasing speed in the same direction. This is not also possible. Now if you look at option C and D, the only difference is the slope. So here you can see this is gradually decreasing, and then in the opposite direction it is increasing. So I think the option C is the best option. Even though you can select for option D also, the only condition for D is we have to assume that there are no resistive forces acting, that is the atmosphere of the planet or something like that. But I think the option C will be the most appropriate one. Now question number 10. Which one of the following graph best shows the variation of total energy E of a satellite orbiting the Earth with distance r from the center of the Earth? The r is the radius of the Earth. Now if you see, it is a very well noted point that the total energy is minus of gmm upon 2r. So it is a negative. So first of all, the positive one all will be get neglected. And how to get this? It is a you must know this, that E total is the sum of kinetic plus potential. Okay, so kinetic is gmm upon 2r, whereas potential is minus of gmm upon r. So you solve this, you will get this expression. So total energy is in negative, so the option is D. Okay, and yeah, question number 11 now. Satellite is in orbit about the Earth. The satellite moves to an orbit closer to the Earth. Okay, now this orbit is moving closer to the Earth, very important. Which of the following correctly gives the change in potential and the kinetic energy? Now guys, please make a note of this. If this is the planet, okay, and this is the, let us say these are the two orbits. So the satellite is moving from this position to the inner orbit, moving closer to the Earth. Okay, now as it is moving towards the Earth, the height is decreasing, therefore potential energy will decrease. And if it is moving towards the Earth, okay, the radius is becoming less and less, so the kinetic energy will increase. Or in other terms, you can also say the total energy is constant. So if one energy is decreasing, the other has to increase. So for this, the option is A only. Okay, and please make sure that infinity it is considered as 0. So if this is, let us say, minus 5, this is minus 3. So minus 3 is greater than minus 5. In that terms also you can consider. Question number 12 now. A spacecraft orbits the Earth. An astronaut inside the spacecraft feels weightless. Now this is very confusing for the student. Weightless means you're not your weight is equals to 0. In other terms, you can say. So this is, what is weight? First of all, weight is m times g. Now mass, we know that it is it is a constant, cannot change. So the thing is that g. Now what happens is the effective weight, what we consider, or you can say the apparent weight, is the not only this is at the surface first of all. Now if you are in a spacecraft, this is called as the g effective. Now in weightless, what happens is the g minus a. Now a also equals to g, then this case gives you the weightlessness condition. So what happens is the acceleration, the same acceleration is towards the Earth. So the spacecraft and the astronaut have the same acceleration towards the Earth. So in that case, the g effective will be 0 and you will consider as a weightlessness. So this is very important and a conceptual part. So the answer is C. I hope I have tried my best. So if you see other part, gravitational field is negligible. No, this cannot be the case, because gravitational field is always there if an spacecraft is orbiting around the Earth. Then otherwise it won't be possible. The Earth exerts equal forces on the spacecraft and the astronaut. So this is again contradicting, because we know that the formula is gmm upon r square. Okay, so the spacecraft and the astronaut mass is different, so there can't be an equal forces. C, I have already explained. Now D, the spacecraft and the equal and opposite forces, again it is impossible. So the option C is the most correct answer. Question number 13. Which of the following correctly describes the nature of electric potential and electric field strength? So we know that potential, again I have said, it is a scalar, and electric field has a direction, it's a vector. So the option is B. Now diagram shows the electric field lines produced by an electrostatic focusing device. This is the diagram. Which one of the following diagram best shows the corresponding equipotential? Now equipotential lines, again it means that at all those points the potential is the same. The electric field lines are shown as broken lines. These are the electric field lines. We know the relation that equipotential lines are always perpendicular with the electric field lines. This we know that. Now again this is not perpendicular. This is not perpendicular. So option A and B are incorrect. Now to select from option C and D, one most important point is like the equipotential lines cannot meet or intersect. Why? The reason being, if they intersect, it means at this point for all these lines the potential is the same, but that is not the case. So if you see here, it is 90° also and they are not meeting. So the best diagram is the option C. Now question number 15, it's a very good question again. The diagram below shows an equipotential in a region. Two lines of equipotential in a region. This is at 50 volt, this is at 100 volt. Of a uniform electric field lines, the X has a potential of 50 and the Y has 100 volt. The distance between X and Y is 2. Which of the following correctly describe the direction of? Now direction is always from higher potential to lower potential. So from Y to X, so these are incorrect. And the electric field strength is V by D, is the direct formula for parallel plates or the between two potential which is given. So this is the potential difference. So 100 minus 50, okay, which is 50 divided by distance is 2 centimeter. So 50 by 2, 25, the option C, okay. Question number 16, the isolated conducting sphere of radius r is positively charged. Which one of the following graph best shows the variation with distance x from the center of the sphere of the electric potential V? Now what is this question is? It's a good question again. This is a conducting sphere, okay. It means the charge will be at the surface. Always remember, whenever we have a conducting sphere, the charge will be at the surface. The variation of distance x from the center of, now this is the, let us say, center, and this is have an electric potential V. So always remember V is k cube by r if this is the radius r and this is x. So inside the conducting sphere, okay, the potential is same. Always remember, inside the conducting sphere the potential is equals to k, which is equals to at the surface, and thereafter it will be inversely proportional to the distance. So if you look at this graph, it is incorrect. This is also incorrect. It is saying 0, but this is not for potential. This is happening for electric field. Electric field is 0 because there is no charge inside, but this is a scalar quantity, so this is constant. It is just in between these, you can say the conducting sphere, the charge is at the surface, but the potential inside the sphere is constant throughout, which is k q by r. So you can say k q by r, this is the radius, and thereafter it is inversely proportional. So option D. Which one of, if it is asked for the electric field, then the option C will be the right answer, okay. Now question number 17. Which one of the following statement about electric potential gradient is correct? Now this is a direct question. If you see the data booklet under the subtopic 10.2, it is mentioned that the electric field is minus of delta V over delta R. So for at a given point, this is constant, so E is equals to minus of delta V, or in terms of magnitude you can say electric field is equal to the potential gradient. So which option? B, which is numerically equal to the electric field at that particular point. Rest all are incorrect. Now question number 18 again, and the last question. The diagram below shows the electric field lines in a region of space. A positively charged particle move from P to Q. This is very important. Positively charged particle is moving from P to Q, and this is the direction of electric field. So if a particle is moving in the direction of electric field, the potential energy also decreases, and if it is decreases means the VQ minus VP, that is the final minus initial, will give you, because VQ is less than Vp, so this will give you a negative value, okay. So the answer will be B for the last part. So I hope I have tried my level best. Again, You can find out the PDF of this video in the link is given in the description. For more videos for other topics, please comment. I will try my level best to upload as much as possible. Thank you.